So what we're going to be doing today is we're going to be adding some A-star pathfinding. We've got our hex engine over here, which is like a cylindrical world, very words, very Civilization style, for example here. So we've got that, and we've got a little dude over here. And he is ready and willing to move around. In previous things, we had it just confirmed that he can move from one tile to another. And he's sort of set up to follow a path, in that we do have a little helper function in here where you can feed a series of hexes. So if you pass a series of hexes to this little fellow, when he does his turn, he will follow. He will walk from one hex to another, or something like that. I mean, we haven't really tested it because we just threw in this like sort of hex path thing. But what we need is some way to create the path that he's going to follow. Now, we've done pathfinding before. We've done a couple of different pathfinding esque kind of tutorials. And we've also implemented pathfinding in Project Porcupine, which is our base building game. So this, what we're not going to focus on today is we're not going to focus on actually implementing the pathfinding algorithm itself. We will mostly take one of the ones we've already written and just use it as is. But what I want to do is I want to avoid the situation where we sort of have to rewrite this pathfinding code in the future. I want to have it set up so that it's a nice, generic, sort of standalone pathfinding class / library, so that we can apply this pathfinding structure to more or less any project going forward. I mean, I think it's still going to be sort of optimized for a, just a 2D kind of map, like a world map or something like that. But otherwise, I want to keep it nice and flexible so that we can just drop it into projects in the future with greater ease. There's some of that in the Project Porcupine version of it, but it still has a good number of hard-coded in references to things specific to that project, including like the tile class and a few assumptions about how things work, which is fine. And there's often going to be a fair amount of tuning and customizing of these pathfinding algorithms to be more optimal and idealized and encompass certain features of various games you work on, and that's okay. But I still want to start from a base that feels like pretty open and flexible going forward. So that's the goal for today. And yeah, we're going to aim for a couple of hours of that. A few people asked, like, oh, you've done A-star before, maybe you should do something like a D-star algorithm. So there are different pathfinding algorithms, different ways to find the optimal path from point A to point B. There are even some that don't literally they're not guaranteed necessarily to find the optimal path, but most of them is they will find the optimal path. It's mostly a question of how long does it take to figure that out. The most basic example is probably something like Dijkstra's algorithm, which can be used for a few different things. It's not exclusively for pathfinding, but it's always guaranteed to find the 100% the best path from point A to point B, but it does it in the slowest, sort of most naive possible way. And then when you've got something like A-star, it's a variant of Dijkstra's, which helps to sort of pathfind in the right direction a little faster. It doesn't have to check as many hexes. And what D-star is, D-star was invented to be sort of to work with maps that would be more changing. The D stands for like a more dynamic kind of thing. No one uses D-star by itself, as far as I know. Instead, there's something called D-star Lite, which actually isn't based on D-star at all, but does something quite similar. And I believe that's the algorithm that is used in things like SimCity and City Skylines, for example. It's quite good for recalculating paths if the world ends up changing on you without having to recalculate the entire path. The idea is if you have a big, long, complicated path and somewhere along the way something changes, it can sort of just like recalculate that little area. I don't believe it's a lot more complicated to implement, and I don't believe it's actually needed here in these turn-based kind of games, because first of all, the world in a Civ-type game, the world doesn't really change very much. The world is pretty static. The worst case scenario is their unit that gets in your way. But that's a bit of a different problem. That's almost more of a collision avoidance kind of thing. And the right thing to do in Civ for that situation is usually to stop the pathfinding. You don't want, imagine there's a mountain pass, okay? You've got a mountain pass, and there's one tile space in there. And you've got a unit back here who wants to get to the other side. So you tell them to like start the move, so it calculates the route and goes through the mountain pass, right? So imagine it's partway through this move, and all of a sudden another unit moves into the gap. Do you want your original unit to then suddenly say, ah, I need to recalculate my path and pick something that goes way around the mountains? No, you don't want that. That would be really bad. Instead, what you want is you want your unit at that point to say, whoa, my current path is invalid. I'm just going to stop my movement and, once again prompt the player to tell me to do something. That is by far the preferable solution in a 4xe Civ kind of game, and that's what they generally do. Now, it's worth noting that in, I think, both Civ 5 and Civ 6, if their final destination, if their target tile in the end becomes invalid because it's occupied or because border situations change, someone plopped the city down, I think in that case it instantly stops moving and asks the player for something because the final destination is no longer valid. However, I think in those games, if one of the tiles in between becomes invalid, the unit will keep moving in that direction, and it'll only stop when it actually, can't get to the next one, which is usually what you want, because what's going to happen in that case, there's often a situation where you're moving multiple units across the map, and sometimes they'll sort of cross in front of each other's paths, but those units are still moving, so by the time your unit in the back gets to that spot, that unit will have left anyway. So that's the sort of behavior ultimately we're probably going to be implementing, although that's not a today thing. But the point is that in a Civ-type game, you very rarely have to recalculate paths dynamically and on the fly. In which case, implementing D-Star Light is not really much of a win. And D-Star is not faster than A-Star. In fact, it's probably going to be a little bit slower and certainly have some more overhead. The reason so many people use A-Star is because it's relatively easy to implement, but also it's a fairly lightweight algorithm, which is really good. And the other thing that you got to remember, in a turn-based game, pathfinding doesn't have to be quite as quick as in something a little bit more real-timey, because you're mostly just calculating the path for one unit at a time, and it doesn't have to be super, super fast to just rip through it. So anyway, that's the case for why we'd still be using something like A-Star in here. Hey, Quill, it's a built-in navigation system in Unity, and you good for pathfinding. Too much overhead. It's fine, actually. And it's got a certain amount of flexibility so that we could use it for other things, but for reasons that will become kind of obvious, we're gonna want to sort of tweak a few things on our own as we go forward, as we make this generic solution that is very well suited for a 2D kind of environment. So that's what we're gonna go. But yeah, the built-in Unity system is also fine. So I think we're gonna get started here. In the game line, there is no reason to implement A-Star. You might as well do in a game line. Oh, a game like this. Maybe. I don't know. This is going to be fine. Isn't A-Star weighted as well so you can take into account movement cost of the tile? Well, there's a few things like that. I mean, any pathfinding system will usually have, will have a weighting system in there. It's not just purely based on distance. So that's one of the other things. And in fact, one of the things we're going to implement is the fact that our pathfinding weights in this game it's not a straightforward question, right? Because normally, like for example, in our the tip system should be running. I've got it open. Let me restart it. Maybe it's just stalled out here. Sometimes the website lags, or sometimes it doesn't send me the info in real time. Yeah, okay, it's going to force me to re-sign in. So then it'll probably work. Excellent. Let me get to that in a second. I just need to finish my thought. One of the things in this game is that the cost of moving from one tile to another is not consistent. It depends on the unit that you are using. What do I mean by that? Well, the cost of walking into a forest tile in Civ is 2. Unless you have a trait that lets you move into forests and not treat it as difficult terrain, in which case, for that unit, it's only 1. Or if you're a flying unit, then it also doesn't cost you anything. And of course, moving into a tile from one direction will cost you 1, but moving in the tile from the other direction, when it involves crossing a river, has a completely different cost. Now, that is a cost based on the edge, like the direction. So that's something you could sort of pre-calculate. But the fact that different units have different costs for moving into different tiles means that certain assumptions that exist for most pathfinding systems will not exist here. In particular, normally when you create your graph. So what am I talking about here? So ultimately, just give me something square here. Ultimately, at some point, you're going to be creating a graph to define your world, because we're not going to be operating on your actual hex objects. I mean, we may or may not, or whatever, but our pathfinding is going to be represented as effectively a series of nodes that have connections between them. Okay, that's what pathfinding is. What you do, step one to make a pathfinding system, is to take your world and turn it into a graph of these nodes and these edges. And it's these edges that have a certain cost. So to traverse from here to there has a cost of, say, 1, right? But to traverse from here to here has a cost of, say, 2. And they might, in this case, in our world, they're not going to be the same cost either. It can be 2 to go down, but only 1 to go up, because if this is a plains and this is a hill, so it's 2 to go that way, but only 1 to go the other way, for example. So we're going to have a bidirectional graph over here, which is fine. And normally when you go and you create your graph, you can actually cache these costs at that point, because it's normally going to be quite consistent. But because different units have different movement rules, we're not going to be able to cache this. We're going to have to check those on the fly. However, one of the things I want to do in our system that we build is I want to have a switch that you can set. You can tell the pathfinding engine when it's building the graph, can it cache these values or not? Because normally it would be much, much faster if you could. So, but in our case, we can't, because, I mean, we could generate multiple graphs, one for things that have, like the fly, one that is a normal walking unit, one that's a walking unit with forest walking, one that's a walking unit with forest walking and hill walking. No, I think that would be crazy. But you could. You'd be a little faster. More overhead, but faster, so maybe it's okay. All right, let's start writing code. So caching, I just mean saving a value. Right? We're going to be constantly recalculating the cost of this movement, like every time we pathfinding, basically. But you could also just save that value if it wasn't changing. So what I'm going to do is I'm going to create a new folder here. I mean, we might want to organize all our scripts into one folder. We'll probably do that later. But for now, we're going to make a folder. We're gonna make our generic, or sort of more generic-y pathfinding system. Should we call it just like QPath or something like that? Something of that nature. And so the idea is we're going to have some initial little function here. I think we're going to use namespaces for this. Right? Because, yeah, sure, why not? This is not going to be a mono behavior. It's going to be default class. In fact, this might be a static or not. We're going to borrow a lot of ideas and do actually some literal copy and pasting from the Project Porcupine thing. But the other thing we can do is offer up a multi-threaded or single-threaded variant of the same thing. It's actually going to be very easy to encapsulate some of that stuff in such a way that it makes it very easy to just call a different function that will automatically set up, say, the multi-threading job for us, which would be kind of cool. So what we want is, well, I mean, we're gonna have to define like kind of how we want this to work, right? What's my automated? How come it's not doing what I want here? There it is. Thank you. So we want to set up a system where we can do something like this: QPath dot find path, and we can feed it in something like, we got to define like some object, which is our world. So our world, we have to tell it the list of what our world is, and this is going to be something. This is going to be something that can return tiles for us. Then we're going to want to say something like start, like tile or position. I mean, tile is fine. We're using hex tiles. A lot of people just think of tiles as a square, but I think of like hexes as hex tiles, so it's probably fine. Our pathfinding system isn't going to give a crap what shape our tiles are. They could be square, they could be hexes. Literally makes no difference here whatsoever. The only difference between them is our tiles are going to have need to be able to return the following information. 1, a list of neighbors. 2, the cost to enter this tile from another tile. That's it. What's interesting about this is at this point, well, that, and even then, this might not be part of the tile itself. Well, maybe, maybe not. I don't know. We'll see. At this point, it doesn't even know that it's going to be dependent on what unit is making the move. I don't think our pathfinding system's going to have awareness of units by themselves. Instead, what we're going to do is make use of sort of delegates and flexible functions like that to have our tile entering cost be offloaded to our unit code through, like, just a little generic function or a lambda or something like that to hide things, and it's going to be nice. So, start tile, end tile. Is there anything else that we need? Yeah, it's going to need a few things. We actually might not want to pass the actual end tile. What we might want to do, and this is one of the things that was set up in the Project Porcupine Pathfinder, is instead have a function, right? A function that is something like, is this our end tile? Because there might be a few different ways that we want to work that out. I don't know if it matters. We'll just say end tile for now, and we can figure something out after. I mean, ideally we want this, and what we want it to do is we want it to return maybe like an array of our path. All right? I mean, in the end, that's kind of what we're looking for. So QPath over here, that's really what we want it to do, is we want it to return this list or this array or something like that. Now, one of the things is we don't want it to be aware of any sort of tile class. Like, we are using hexes, right? Our hex class is just called hex. Sometimes it might be tile, like in Project Porcupine. Sometimes we might call it something completely different. So we're actually going to want another function in here. And this is going to be something like, we're going to call it something like QTile. Pathable tile? Oh, you know what? It should just be an interface. Pathable tile. I think I like that the best. So the idea is public interface pathable tile. And it's going to be in the same namespace. Which I think there's a faster way to create classes within a namespace like this, but that's going to be okay. There we go. Where's the chat? I'm missing this. Yeah, make it interface. Yeah, I think that's the best way to do it. So the idea is QPath doesn't care what our tile object is. It doesn't give a crap whatsoever. As long as it implements the iPathable tile interface, which is going to ask for something like, it's going to have some sort of function that's going to return, say, an array of other iPathable tiles and something like get neighbors. I think that's fine. What are you complaining about? Is it implied to be public? What am I going? I'm going crazy about something here. C# interface. I mean, maybe. I guess. Maybe? I don't know. Well, we'll sort it out later. Yeah, it's implied to be public. Yeah. I was going to say, because it's an interface, so an interface would have to be public, so it must be. I don't do a lot of work with interfaces, so every now and again it'll catch me something like that. So we've got something like that, and then I still don't know exactly how we're going to... And the important thing as well here is that we're going to be working with aggregate costs, which is something, if you watch the last tutorial, is something we looked at. We want to be able to know this function is going to have to take in something like this. So it's going to be some sort of float. Aggregate cost to enter. Float. It's going to take a float that is going to be something like cost so far. And then it's going to take in another iPathable tile, source tile. So this is one of the things that's going to be a little bit different. Normally, you just say, what is the cost to enter this tile, which is going to define the edge cost. But here we're going to take in a cost so far, and then we're going to return the new total cost, which is going to be the cost so far plus the cost to enter the tile. Usually you don't do this, but we have dealt with our last video. We went through an explanation of why we need to do that here, because the funny thing that happens in a Civ-type game is that the cost to enter tile is a little bit loosey-goosey, because if you don't have enough movement, so if it costs you 2 moves to enter a forest and you only have 1 move remaining, can you enter the forest this turn or not? In Civ 5, the answer would be yes. In Civ 6, the answer is no. Which means in Civ 5, let's say you have a unit with a maximum move of 2, and you have 1 move left, and you're supposed to pay 2 movement to enter the forest. Effectively, you're only paying 1. So in Civ 5, you get a 1 movement point discount to entering the forest, where in Civ 6, you can't enter the forest with only 1 of 2 moves. So you have to wait to the next turn, at which point you use your full 2 moves, which means, in a sense, it's cost you 3 moves to enter the forest, because you wasted 1 last turn. So there's a massive difference. The forest has a movement cost of 2, and yet it might end up costing you 1 or 3 to enter the forest, depending on what the movement rules are in your particular game. Which is why we're going to need to know the cost so far, which in this case is going to be in terms of number of turns spent, right? You've spent 4.5 turns worth of movement to get to this point, and to enter this tile, because we're using Civ 6 rules, it's going to cost you a total. We're going to return a total of 6 turns at this point to enter that tile. So you had 4.5 turns worth of movement used up. To enter the tile, you now have to have 6. Or if you're in Civ 5, it'll return 5. So you came in with 4.5 moves, and to enter that forest, it'll bring you up to a total of 5. So we need to know that information. Yeah, this is all going to go on the Quilly Team Creates channel afterwards. So anyway, that's the sort of, we implemented that logic last time. We don't have the actual cost right now. All the tiles are still just worth 1, because the tiles themselves in the game don't really know what they are yet. That'll be the next step. I just want to get this basic thing going. So we're going to have something like that. So that's what, to be an iPathable tile, we're going to need these 2 things. I think only these 2 things? We'll find out. So we need our hex. For this to work, we need our hex to implement iPathable tile. Which is going to require that we add a reference to using QPath because of the namespace. And now if we tried to compile this, we would get an error because Hex does not implement. It needs 2 functions. Get neighbors and aggregate cost enter have to be implemented in the Hex function over here. Now, and that's why I'm like, there's a problem with this, because the hex itself isn't the thing that's going to do the aggregate cost enter. It's actually the unit's job. Well, I mean, right now we have it as the unit's job. Maybe it should be the hex job, but the hex needs to know. In our game, the hex cannot answer the question of the cost to enter unless it knows the unit that is trying to enter it. Hey, I want to say a great big thank you to all the June Patreon supporters and these Mic Check supporters. We've got Yukofin, Eric Sumner, Tiburon, Mighty Mix, Pavel Zdanov, Drazion, Michael McClintock, Aaron Toyson, Craig Mortel, the not-so-evil engineer, Julien Auger-Lafont, Marius Fieldvold, Speedy Savant, Valiant Cakefiend, Thomas Oberson, Jason Yanity, Stephen Bonnerman, Kale the Quick, and Neil Blakey Milner, and absolutely everyone who watches, shares, favorites, and subscribes to these videos. Thank you so, so much.